Hello and welcome to the first subtopic in the overview of the numbers in GCSE Maths. What we're going to do is square and cube numbers, prime numbers, triangular numbers. We're going to do some worked examples and a few things to avoid. Now, if you're watching this on YouTube, you can press the link in the description to go and view the practice paper and the mark scheme. If you're on my website, then if you just scroll a little bit below, you can also see the practice paper and the mark scheme. I highly recommend after we've gone through this lecture that you go and attempt the questions yourself, and if at any point you get stuck, you can always refer back to this video. So let's just start. The first thing we have a look at is types of numbers. So before anything else in GCSE Maths, you need to be fluent in the different types of numbers that come about. They show up as a standalone questions most of the time, or they are integrated into other types of questions, right? They're very, very foundational, and so if you don't get a specific topic on types of numbers, then it's not that, I've taught you the wrong thing. It's the fact that these are just, in everything. And so it's sort of like assumed knowledge. So we've got square numbers. These are things like, 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9, and so on and so forth. Then we've got cube numbers, which is 1 cubed, which is 1. We've got 2 cubed. And remember, the indice or the power on the top right of your number is telling you how many times to multiply this number by itself. So 2 squared is 2 multiplied by itself twice, so 2 times 2, which gives you 4. If you have a 3, it's not going to be 2 times 3, it's going to be 2 times 2 times 2, because that is 3 times, and that is going to be 8. Then we've got 3 cubed. Again, it's going to be 3 multiplied by itself 3 times, so that is 3 times 3 times 3. 3 times 3 is 9, 9 times 3 is going to be 27, and that continues as well. And so then if we look at the prime numbers are numbers that can only be divided by the number 1 and itself. And so you have many examples of this. We can call 2 a prime number because the only factors of 2 is 1 and 2, which is 1 and itself. We can also look at 5 because 5 is just 1 and itself. We can look at 11. 11 is 1 and itself. You can't break that down into any more numbers. So there's no more factors for these. So there's many prime factors or prime numbers, and we're going to do a few more things on this, but let's just focus on identifying them first. We've got 7, those types of things. Now, one more thing, 9, I know it's an odd number and it's very easy to confuse prime with odd, but 9 is an odd number, but it's not prime because you can split that into 3 times 3, right? 3 times 3 is 9, and so 3 is a factor of 9. Therefore, the factors are not only 1 and itself, it's something else, and therefore 9 is not going to be prime. So, and then we can look at triangular numbers. Triangular numbers they're quite funny because they don't come up that often, but you still need to understand what they are. They sort of follow a pyramid. So you have 1, and then you've got 2. So the triangular numbers are 1, 2, and then you've got 3, and then you've got 4, then you've got 5. So we've got that many dots, and so the first triangular number is 1, the second triangular number is 3, so let's just add these up. So we've got 1, we've got 3, and then we've got 6, then on top of 6, then we add 4 to that, we've got 10, And then this keeps on going on as well. You just keep on adding the previous dots, okay? And so we've got 1, 2, 3, 4, 5 dots, and then as we go down, we just keep on adding them, okay? So these are sort of like the foundational numbers that we should all know. If we move on, let's go a bit deeper into square numbers. So a square number is what you get when you multiply a whole number by itself. So the first 10 are 1, which is 1 squared, 4, which is 2 squared, 9, which is 3 squared, and so on until we get to 100, which we know is 10 squared, because 10 times 10 is 100. And we use the power notation, so it's that small number on the top right of the number. 7 squared, that's how we read it out, means 7 times 7, which is 49. And if you want a little visualization, it looks like this. So that's 1 dot, which is 1 squared. This is 4 dots, which is 2 squared. And this is why they're called square numbers, is because they form triangles, right? It's the area of a 2 by 2 triangle. Not triangle, square, sorry. This is going to be the area of a 3 by 3 square. And this is going to be the area of a 4 by 4 square. And that's why they're called square numbers, because they represent the area of that unit square. So, these come up on every paper, First, you should know that at least the first 10, so 1 through 10, you should know these by heart, memorize them, because in a lot of further topics and a lot of the more advanced topics, you will need to be able to identify these relatively quickly. Okay, so make sure you do have some practice on those. Now, a cube number is when you multiply a whole number by itself 3 times. So you can imagine, we've got a number squared, and then we've got a number cubed, and then this can go on once we go into powers, because you can have it to the power of 4, to the power of 5, so on and so forth. The first 2 just have special names because they represent something really visual, which we can all identify, which in this case is a square, and as you're going to see with this, cubes. So the first 5 are 1 cubed, which is 1, 2 cubed, which is 2 times 2 times 2, which is 8, 3 cubed, which is 3 times 3 times 3, 27, and so on and so forth, as we discussed. And again, it's written with the power notation with that small 3, 4 times 4 times 4, which is 64. And the visualization of this is cubes, right? Because this is a 3 by 3 by 3 cube. And so if we want to work out the volume of that, it's going to be 3 times 3 times 3. And that's going to be the volume of a 3 by 3 by 3 cube. So keep that in mind. Again, this is something that you just need to be able to identify. Ideally, you'd want to memorize the first 5. It's not compulsory, but it's just good to have. It's good knowledge to have in your back pocket. Now, prime numbers. So a prime number has exactly 2 factors, 1 and itself, as I discussed before. And the first 10 primes are 2, 3, 5, 7, 11, 13, 17, 19, and so on. Now, to check if a larger number is prime, you test whether it divides exactly by the small primes in turn, up to its square root. Okay, so we've got these being prime, we've got 2, 3, 5, so on and so forth. And so if we want to test, I don't know, let's say if 30, we want to test if 30 is a prime number. Let's say, is 30 prime? Question mark. Okay, so what does it tell us here? This is a quick test. There's many tests you can do. I'm not sure if your teachers have taught you these, but one of the tests I would run is test whether it divides exactly by the small primes and do it in order. So first of all, the first small prime is 2. Can 30 divide by 2? Yes, it can. So 30 divided by 2 is 15. And immediately we know that 30 is a composite number because it has more than 1 and itself as factors. So that's a quick test. I do recommend you try this on different types of primes until you've convinced yourself that this is a viable test to run. Okay, one thing to note here is that 1 is not prime. 2 is the only even prime. Okay, 1 is not prime because, well, 1 times 1, right? It has the same factor. And so remember, it has to be 1 and itself, and in this case 1 is itself. And so it sort of like goes against the definition of what we have for prime numbers. But that's just an exception. If we continue forward, you know, I'm sure you're going to see that all of the primes follow the same rule. Now, is 91 a prime number? So 91 is not even. Therefore, if we do 91 divided by the first prime, we're not going to get a whole number back. Not whole. Just write that here. Then, and it does not end in a 0 or a 5. Okay, that's another test. If it ends in a 0, it's not prime. If it ends in a 5, it's not prime, because we know immediately we can divide by 5 if that is the case. So it's not divisible by 2 or 5. Okay, now we can check 3. So digits add to 9 plus 1 is equal to 10, which does not divide by 3. So 91 is not divisible by 3. And again, these are little tests we can run, okay? Because if we add the digits of a number and we divide them by 3, we should be able to divide into it to show that 3 is a factor of that number. And in this case, it is not the case, and therefore we can't divide 91 by 3. So it's checked this box. Well, I'll put a cross there so to show that it's failed. It's failed this one as well. And then we can also check 7. So 91 divided by 7 is 13, which is a whole number. And because it's passed this test, right, therefore we say that 91 can be easily written as 7 times 13, meaning it has factors other than 1 and itself, so therefore 91 is not prime. Okay, and so these little tests that we run to see if it's a prime are just, you know, they're little gimmicks. And the more you do these types of questions, the more you will sort of have an intuition on how to answer these questions or how to identify it quickly yourself. These are little things that I would recommend, but you can completely do different things. If your brain works a bit differently to mine and you identify it in a different way, by all means do that. This is just some little recommendations that I would highly suggest you learn. Especially the digit check with the 3. And then the 7, whatever means you want. But the point is, we are checking the earlier primes. We're checking these primes to see if they divide into the number, and if they do, then we know it's not prime. Okay, so the answer to this question would be no, 91 is not prime because 91 is equal to 7 times 3. So moving on, triangular numbers. They come up from stacking dots into a triangle. So 1, then 1 plus 2. So remember what we did before. We had this is 1, this is 2, this is 3, etc. And we just add them as they go along. So the first one is going to be 1, the second one is going to be 3, the third one is going to be 6, and so on and so forth. So if we want to know the 5th triangular number, so we're representing it as t with a superscript 5, that's going to literally be 1 plus 2 plus 3 plus 4 plus 5 until we've added 5 numbers together with them increasingly being consecutive. So these are consecutive, so on and so forth, and you end up with 15. And so if you wanted the 10th triangular number, you do 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, add them together, and then you get the 10th triangular number. Okay, so there is a formula for this, and it's represented as n multiplied by n plus 1, all divided by 2. And so if you wanted the 5th one, you would substitute n is equal to 5 here. So you'd have 5 times 5 plus 1 divided by 2, which would end up being 5 multiplied by 5 plus 1, which is 5 times 6, which is 30. And then divide that by 2, and you end up with 15. And so there's a basic way to calculate them, and there's also a formulaic way to calculate them. Okay, you'd ideally want the formula if you're doing bigger triangular numbers like 10, 20, 30. The smaller ones you can just very quickly do in your head, 1 plus 2 plus 3, so on. Moving on, was there a little note here? Yeah. So write down the value of 7 squared. This is easy, right? So this is just a recap of what we've done. The first thing is 7 means 7 multiplied by itself, right? So 7 times 7. 7 times 7 is 49. Our answer is 49. Okay. Very straightforward. If you're given this on your exam, you're more likely to get it on the foundation paper, not the higher. A simple question like this, 3 marks. The next question is square or prime. So check, so it's saying 8, 9, 11 and 14. So we need to check these numbers. Check each number in turn. So 8 is equal to 2 times 2 times 2, which is a cube number and it's not a square. So 8 is not a square. But is it a prime? I know it's not prime because 2 divides into it. So it's not square or prime. So I'm just going to say not square and not prime. Okay, NP and NS and NP. Then we look at 9. 9 is 3 times 3, which is a square number. And what's it called again? Because it has factors 3 and 3, it's clearly not a prime. So it is a square number. So 9 is a square number. Let's just write that, square, but it's not prime. And by definition, if something is a square number, it's not a prime number. Because if we're assuming it's a square number, then that will always have a different factor, right? So 5 times 5 is 25. We know immediately that's divisible by 5, which is not 1 and 25. Then 11. So 11 only has factors of 1 and 1, which is a prime number. And it's a prime number and it's not a square number. And so 11, right, it's not square, but it is prime. And then 14 is divisible by 2. And so it's 2 times 7, as it shows here. But it's not even a square number either. So 14, if we look at it, it's not square because there's no number multiplied by itself to make 14. But it's also not prime because it's still divisible by 2. It's an even number. And so the square number is 9 and the prime number is 11. So we've identified that 9 and 11 are the numbers we're after. And so, you know, if it's a square number, we've identified it to be 9. And if it's a prime number, we've identified it to be 11 in this list. So I know I've sort of gone above and beyond and looked at each individual number. In the exam, or if you've done a lot of practice, you should be able to do this relatively quickly. So is 51 a prime number? So again, we're going to do the test. Test whether 51 divides exactly by small primes. So it's not even, so 2 is not going to go into it. If you add the digits together, right, 5 plus 1, you will get 6, and 6 is divided by 3, which is equal to 2, which automatically shows that we can divide 51 by 3. And right here, it's showing that 51 does divide by 3 because it's equal to 17. But we did the digit check that we did in the previous slides. And so 51 is 3 times 17, meaning it has factors. Therefore, 51 cannot be prime because 51 divides by 3, which is 3 times 17 is equal to 51. So these are a few examples of how we would approach these questions. And now finally, just a few things to avoid is thinking that 1 is a prime number. It only has one factor, so it does not meet the definition of a prime, as we discussed before. This is a big thing that a lot of people confuse, is that working out 4 cubed as 4 times 3, remember the cube or the small number on the top right just means multiply the big number by itself that many times. So 4 cubed is not 4 times 3, it's 4 times 4 times 4. Okay? The small number tells you how many times to multiply, not what to multiply by. Then we have confusing square numbers with even numbers. A square number can be odd or even, right? Because 9 is a square number, 25 is. Whereas 9 is odd and 25 are odd as well. Whereas 4 is a square number, but it's also even because you could divide by 2. Now, using the triangular number formula, but forgetting to divide by 2. That's very important. Remember, the formula is n multiplied by n plus 1. divided by 2. Once you've worked out your top numerator of the formula, you must divide by 2 at the end. Okay? And then on give a reason question, writing only yes or no without showing working or an explanation. The examiner rewards you for what you can show them that you know, not what you know in your head. Okay, remember that. It's very important. GCSE Maths is not the same as Maths. You might know Maths, but you don't know how to do GCSE Maths, which is getting the marks, getting the grade that you want. So, that would lose the mark if you just say yes or no. You need to give a reason. You need to give a conclusion to some working out. And finally, types of numbers are just a few more building blocks that you need to remember, and add to what you know about maths in general. Think about each of them as a foundation, as I talked about before, that other topics are going to build on. We're going to go into many more advanced topics, and these are your foundations to those topics. So thank you for your time. If you press the description link, you can get the practice paper and the mark scheme. And if you need GCSE Maths tuition from myself or anyone on the Teachably team, then please do book a call with myself, and I can see where I can help to make sure that you get the GCSE Maths grade that you want, to ensure that you can get into the college that you want. Thank you so much for your time. I'll see you in the next lesson. Bye.